Now let's go ahead to find out the centers of triangle. So we know there are various centers: centroid, intersection of median, where median bisects the opposite side; circumcenter, intersection of perpendicular bisectors; incenter, intersection of angle bisector; and orthocenter, intersection of pure perpendiculars. So first I start by drawing the perpendicular bisectors on the three sides of the triangle that you can see. And I see the intersection point and I draw a circle out of it. Now can you tell me which is this circle? This is a circumcircle because I used perpendicular bisector. The point of intersection of perpendicular bisector that I get is called as a circumcenter. So D is a circumcenter of the triangle ABC, where three that you can see on the sides are perpendicular bisector. They are perpendicular as well as bisecting the side. So I draw it in red right now. This 3 red represents my 3 perpendicular bisectors which are perpendicular to the 3 sides of the triangle and bisecting them. So I know D is my centroid. With that I draw a circumcenter and a circumcircle. Now let's draw this blue. What is this blue? Can you guess? This is nothing but an angle bisector. It is bisecting the angle A, B and C. So what is the intersection point of angle bisector called as? It is called as an incenter. So I get E, which is an incenter of triangle ABC. Okay, we can very well see that it's an incenter. With the incenter we get something called as a incircle. So circumcenter gives me circumcircle, circumscribing the circle. Incenter gives me incircle, which is inscribed inside a circle. So can I draw an incircle here? Yes, I can. With E as a center, I can draw this incircle, and that gives me a visual proof of incenter making an incircle. And I also know how a circumcenter makes a circumcircle. Now last, let's see median. So I get the midpoint of one of the sides as H, and I draw a median. You can see BH is a median which is drawn on to the side AC. So it is bisecting. As you can see, H is a midpoint of side AC, so it is bisecting the side AC. Similarly, I draw J is a midpoint of side BC, which means it bisects the side BC. And similarly, I draw I as a midpoint of side AB, which is bisecting this, and I join the vertex to the midpoint. What is this called as? Median. Okay, because median always goes from the vertex onto the opposite side and it bisects the opposite side. So I know, and the intersection point of the median is called as a centroid. So let's see this K which I get it here, intersection point of the green. Okay, green is our median. So that is nothing but a centroid. So I have all the 3 centers which are in front of me. I have a circumcenter, I have an incenter, as well as I have a centroid which are straight here in front of me. So D is my circumcenter, E is my incenter, and the K which I see here is a centroid. Now let's see how does this 3 centers change when we make different triangles. So first I'm trying to make a triangle which is an equilateral triangle. In an equilateral triangle, all the centers are same, hence proved. We can see it here. If I go ahead to make an equilateral triangle, all this 3 center will come at one point. Okay, so we visually prove that in an equilateral triangle, all the centers are one and the same. So your centroid is equals to circumcenter is equals to incenter. What if I make a right angle triangle? Let's try and see what are the properties associated with the centers of right angle triangle. Can I prove it here visually? So let's see, I make a right angle triangle. So one of the angle is 90 degree, quite visible to us. Side opposite to that is an hypotenuse. Midpoint of the hypotenuse is my circumcenter. So the circumcenter comes on the midpoint of the hypotenuse, something that we have studied in a right angle triangle, which says that circumradius is equal to the half of the hypotenuse. Now we know why. Because your circumcenter comes and lies on the midpoint of the hypotenuse. That is why your circumradius of a right angle triangle becomes half of the hypotenuse. So R is equals to R. And that is how you can draw a circumcircle in a right angle triangle. So this is again a visual proof of the property which we already knew related to a right angle triangle, that that the circumradius is always half of the hypotenuse. Now we know what is the reason. Last, the orthocenter is always the intersection point of perpendicular. So in a right angle triangle, you can see the orthocenter will be at the vertex, because you can see two perpendicular comes from two sides, and I can take one perpendicular from the hypotenuse. So the orthocenter will be at the vertex. Okay, so this also proves the property that we know about a right angle triangle. So if we just keep on playing with this triangle, the circumcenter, median and the incenter will keep on changing. If you can see, this is just keep on changing, and if I again make it equilateral, what will happen? They will coincide and will come at one point. So we can visually prove everything that we have learned with respect to the centers. In an equilateral, all will be at one point. Yes, we proved it here. So this gives us a visual proof related to the different centers of a triangle.